I'm Jennifer Ludlam with Dynamatic, and I'm speaking with Michael Kogan.
And I am Michael Kogan with Quality Controls. We are the reps for Dynamatic in Southern New York, New Jersey, Eastern PA, Delaware, Maryland, and DC.
Michael, I have a lot of customers who often ask, why are we so advantageous to operation of pump and startup versus other technologies? And I often mention it's something about how we are not coupled to the driven equipment when we start up. Do you want to elaborate on that?
Yeah, this is somewhat misconstrued with a lot of the users out there. All technologies that offer speed control can soft start, can ramp up slowly. The difference is our device only calls for power as it's needed. So in essence, we can start the system with just the motor without having any engagement with the load at all. And then slowly we can introduce that torque to the system. And that's the true soft start, slow ramp up. Whereas the competitive technology, yes, they can start it at 1 RPM, 2 RPM, but they're still having to push the weight of the process as well as the inherent torque of the driven load, whether it be a pump, compressor, blower, whatever it be. They're still having to overcome whatever inherent inertia is involved in the system.
So if it's a large diameter pump or a heavy fluid that you're trying to start against, that's going to cause the motor to start up much slower and also require a lot more power to get that motor to start up.
Yeah, it's a lot to ask of the motor, which is one of the, well, not one of the reasons, it's the main reason why for us in a retrofit, for example, we're not heating up the windings of the motor, so you could theoretically keep your existing motor. While it's not recommended if you're going to do a change and upgrade like that, you might as well get a new motor. But the reality is you don't have to. Whereas with competitive technology, the heat that is generated by pushing forces at a slower speed than that motor is used to or wants to spin at creates a lot of wasted energy out through the windings, and it shortens the life of the motor.
And that actually brings up another topic of why it's better to run with an eddy current, because the motor is always running at its design speed, which means it's cooling at its design speed. So it's not going to overheat as much or with an eddy current drive, whereas other technologies, the motor actually has to slow down the pump, whereas an eddy current does not, because two pieces are not coupled together. It's a magnetic coupling. So therefore, the motor is always running at its optimal design speed.
Exactly right. And in a lot of discussions I've had with engineers over the years, there's always somebody who, well, your drive heats up, and that's true. And that heat is an inefficiency, and that's true. However, the competitive technology manifests its inefficiency inside the windings of the motor, as well as the electronics of the device itself. And compounding that is the fact that if you let it go unchecked, it will destroy itself. Whereas our device is designed to mitigate that just by the rotational movement of the device. The alternative technology requires, in some cases, an entirely dedicated HVAC system to keep those electronics cool. So yes, there's inefficiencies, and in both cases it manifests itself in the form of heat, but in looking at the overall efficiency and how it's mitigated, it's far simpler with ours. We're a fan, essentially.
Okay. Well, thank you, Michael.
Sure.